Today we're going to be looking at plate boundaries, and this lesson does involve a lab that involves food. So that is something to definitely look forward to as we get through these notes. So let's look at our first plate boundary. The first type of plate boundary we have is a divergent boundary. Think about when you hear the word divergent, you usually think divide. So divergent boundaries are going to be when you have two plates that are dividing or separating from one another. So the plates are going away from one another. I'm also going to draw pictures of each boundary as we go, and these boundaries need to be drawn within your notes. So when you have a divergent boundary separate, they kind of form these little bumpy things. And these little bumpy things are what we call ocean ridges. So let me change my color. So these little bumps, these are the ridges, which is also what you see up here. That's the ridge, those little bumpy looking things. And then they create what we call a rift valley. So if you have a rift between you and someone, that means something is separating you, something has come between you. So rift just means to separate, rift right here. So this lower area where these have separated, this is the rift valley. And sorry, my handwriting is so horrible. Yeah. Oh, well. Rift Valley, you know what that says. Now, think about what the crust is sitting on. All of the crust is sitting on top of the mantle, and the mantle is made up of magma. So if you have two plates that are separating and going away from one another, then that means that magma from down in the earth is going to come up and fill in that space in the Rift Valley. So when that magma cools and hardens, that's going to create brand new rock, so brand new ocean floor. So your divergent boundaries talk about how it creates new sea floor, also called a sea floor spreading center. Well, that's because as these plates go away from one another, that magma comes up, cools and hardens, and that is what creates the new ocean floor. Now, think about that magma bursting up from the ground. It's not just going to come up and make a nice, smooth little layer. It comes up and it just bulges up out of the ground real quick and then cools and hardens because of that water. That's why you have these ridges. Now, it's very important, as I said in the previous set of notes, that you know every single boundary and all of their features. And it's best if you, instead of having to memorize every single thing, because that's going to get hard, if you can actually think through them and understand how some of these features are made, it's going to make it so that you can more easily remember it because you'll be able to visualize it. So I want you to think about if you have two ocean plates that are scooting away from one another, visualize that magma coming up through that little crack, bubbling up, cooling and hardening to make a little bump. And then it continues to do that, so another little bump gets made, and that's what's making all of your ridges. And then remember, as it's being pulled away in the middle, that's what's creating that low line area, that rift valley. So that is your divergent plate boundary. So you've got new sea floor, ocean ridges, and rift valleys. They can ask you questions like, a rift valley is made at which feature? Or they can say, which of the following features are a part of a divergent boundary? Or they could give you a picture, like the one above, and point to something and ask, this is the what? So the bumpy things are the ridges. The middle part where it's the lowest is the Rift Valley. And when that magma cools and hardens, that is the brand new sea floor. So if you haven't finished writing this and drawing it, then you can pause the video to continue to do that. Otherwise, I'm going to move on to our next boundary. So I'm going to clear the screen. Hopefully if you need to pause it, you've done that. Okay, next boundary. All right, well, here's another picture before we move on. So here is where we live, obviously, North America. There's an X about where North Carolina would be-ish. But this boundary right here, going down the middle, that's your Mid-Atlantic Ocean Ridge. So notice it says it's a Mid-Atlantic ridge. Ridges are made at which boundary? A divergent. So if they ask you something like the Mid-Atlantic Ocean Ridge is what type of boundary, you would know it's divergent because you know ridges are made at divergent boundaries. You can also see here in this picture some of the little bumps in the ocean floor. Those are those ridges, so we know that black line would show where the Rift Valley is and where the newest of the seafloor is also being made. So this continent, or this shelf, because again, your divergent bound, or all plate tectonics, they do not just hug where countries are. They just form their own plate. So this plate is going this way while this plate is going this way. So they are dividing away from one another. And again, in this picture, you can also see those ridges. You can see the Rift Valley. You can see how that magma is coming up to fill in that gap. So that is your Rift Valley. And I think I have a picture on the next one too. This is the Africa's Great Rift Valley. So at one point, this Rift Valley would have been underwater. At one point, this place would have been covered in ocean. And there's a person standing right here, so you can kind of tell just how large this area is, how deep the valley is. But this would have been one of the ridges where it's very bumpy, but for us, it now just looks like mountains. So this is the Rift Valley that is now just filled up with grass and stuff like that. But you can see how it formed. It was spreading out from the pictures there. So now let's look at our next boundary after the brain teasers. So think about what this says. You can go ahead and pause the video while you think about it, and then after a moment of thinking about it, you can raise your hand and share if you think you have the answer. Okay, here's your next one. This one I think is my favorite, but it's pretty hard. So figure out what this one says. And our last one, what does this say? Okay, now we're going to look at our second type of boundary. So we talked about divergent and how divergent divides. Convergent boundaries are going to come together. So with your convergent boundaries, you have the plates that are actually coming towards one another rather than dividing. There are 3 kinds of convergent boundaries. The reason we have 3 different types of convergent boundaries is because there's 2 different types of crust. You have ocean crust and you have continental crust. So the way we get these different boundaries is you think of the way that these 2 things could be converged or connected. So you could have 2 ocean plates come together. So we could have ocean and an ocean. You could have an ocean and a continental plate come together, or you could have a continental plate meet up with another continental plate. So because we have the 2 types of crust, ocean plates and continental plates, that's what gives us 3 combinations in order to create our 3 different convergent boundaries. So we're going to look at each one of these boundaries individually on the next couple of slides, and that will show you the different features and all that stuff. But you need to make sure that you understand why it is that there's 3, and that's because you have the 2 types of crust, and that creates the oceanic, continental, 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 and oceanic, oceanic. And as we go on with notes, if it helps you to write faster, you are welcome to do the O-O, O-C type this stuff. But if you do that, make sure you make note of it here so that when you look back over your notes to study, you know what you're talking about and you don't forget. So I'll give y'all a second to finish writing this down. I'm going to clear the screen and move on. If y'all still need more time, you can pause the video. Otherwise, I'm going to keep going. Okay. Oceanic continental, this is the first one. Remember, this is a convergent boundary, so I'll write convergent up there for you. We're still looking at convergent. So we're still looking at convergent boundaries. This is just the first of our convergent. So oceanic continental convergent boundary. That's when we have an ocean plate combining with our continental plate, which you can see in this picture down here. There's one ocean plate and it's meeting up with another continental plate. there are three features is what we will call them, that are created at this type of boundary. You have your subduction zone, you have a trench, and you have a volcanic arc. So let's go ahead and work on our drawing. So we know that we have one ocean plate, so this will be my ocean plate, that is going to converge with a continental plate. And we'll do green for continent. So it's converging with this green continental plate. Now the ocean plate is more dense than the continental plate. Why is it more dense? Well, it's soggy. It's soaked up a bunch of water. So because of that, it's going to be a lot heavier. And so that ocean plate is actually going to be the plate that is going down below the surface because it's more dense. So we have ocean plate and a continental plate, and the ocean plate is going underneath of the continental plate because it's going to be heavier due to all that water. Now, the prefix sub, think about submarine. Submarines go under water. So when you're looking at sub, you need to think under. So subduction zone, it just means the plate that is going beneath the other plate. So this is the subduction zone. It is subsiding below the continental plate. So now I want you to think about, if you have this ocean plate that is going down below the continental plate, as it continues to go down into the earth, what is it eventually going to hit? Well, eventually it's going to end up hitting magma. This is all magma down here because it's going down into the mantle. Now, just like if you burn something at a fire, you have a lot of ash and smoke that is left over. So as this plate is going beneath the magma, it will start to melt and it's going to release a bunch of ash and smoke, and that comes up to the surface, and that's what creates volcanoes. So that is a volcano. And that's where we get our continental volcanic arcs. We call them a continental volcanic arc because they are on the continent side. Now, the last thing that we have to look at are your ocean trenches. So your ocean trench is always going along the subduction zone. So this, I can't write on this thing. This deep valley area, this is what the trench is. So this valley area is the trench. Think about in Finding Nemo. There's one part where the dad fish is, I don't remember who's talking to him, but the turtle or something says, when you get to, or maybe it's the shark, but it says when you get to the trench, you're going to go through the trench, not over the trench. And he's too scared, so instead he goes over the trench, and that's where they meet a bunch of jellyfish, and Dory gets stung. So that was an ocean trench. The ocean trenches are some of the deepest parts of the ocean because you literally have the ocean crust that is sinking down underneath another plate. So because that is occurring, ocean trenches are some of the deepest zones of the ocean. Now, this valley, if you notice in the picture that is over here, the trench is going along the entire part of the subduction zone. So this isn't just like one little hole in the ground. It's just an entire long valley. It could be 3 miles long or something of just really, really deep ocean water. So you have your ocean crust going below the continental crust because it's more dense, it's heavier with water. When you have that crust going below, that's what we call the subduction zone, because sub means under. The magma is going to melt that crust, and it's going to send up a bunch of smoke and ash, which vents through the earth on the continental side as a volcano. And along top of the subduction zone is a trench. So that's your drawing for this one. If you need to pause the video to finish drawing this, then go ahead and do that. I'll just wait for a second in case you do need to pause it. Otherwise, we're going to move on to our next boundary, and I'm going to show you something very, very simple about it. So go ahead and pause this if you need to, and then I'm going to show you something before I move the slides. Okay, our next slide that I'm about to go to is going to be an oceanic continental bound, or oceanic convergent boundary. But I want you to pay close attention. So I want every single person to look up at this screen. Look at my drawing for all the different features. The only thing in the next slide that I'm going to change when I do the drawing is this. That's it. For the oceanic convergent boundary, the only difference is it's two ocean plates colliding. They create the exact same features in the exact same way. So when I do this drawing, don't get overwhelmed and think, oh my gosh, there's so many different features. It's the exact same thing as oceanic continental, but it's two ocean plates rather than two continental plates. So I'm going to clear the screen, go to the next slide, and then I'm going to redraw this beautiful diagram. Okay, so, here's your model picture. As you can see, you have the continental crust that is going this way. You have the ocean crust going under, which again is the subduction zone. Along the entire top of the subduction zone is the trench up here. As the subduction zone goes down into magma, it starts to melt, vapors and ash and stuff like that gets released, creating a chain of volcanoes. So that's your continental oceanic convergent boundary. Again, when we take notes on this very next one, the only difference is it's going to be two ocean plates creating the exact same features. So let's go ahead and take a look at that. Here's your oceanic, and again, remember this is still a convergent boundary. We have only talked about two different boundaries, a divergent where they divide, and then a convergent where they come together. So this is still convergent, it's just another type of convergent. So here we have the exact same thing going on. You've got two ocean plates colliding. One ocean plate goes under the other one. Doesn't really matter which one. So one plate goes under the other one. And remember, as that plate is going below, that's what we call the subduction zone. So I'm just going to put sub. That's the subduction zone. As along the top of the subduction zone is always a trench. And then as that plate is going down into the mantle, it's being melted, and you've got ash and you've got smoke, and that comes up to create a volcano. So we have the exact same three features. We have a subduction zone with a trench, and then we've got volcanoes. The only difference is here, these volcanoes are an island. On the other one, we call them continental volcanoes because they were on the continent, but here they're an island because they're surrounded by water, which makes sense because you have two ocean plates coming together. So obviously there's a lot of water around that area. So you had divergent where they divide, and they made a ridge with a rift valley and brand new ocean floor. Then you had the oceanic continental with the trench, subduction zone, and volcanoes on the land. And now we have oceanic convergent with trench, subduction zone, and volcanoes that are islands. So those are all of your features. Again, you've got to make sure you know your features. If you want to do well on this test, then study. If you don't want to study these different features, or you don't want to try to understand them and you're not paying attention right now, go ahead and expect to do poorly on the test. That's just kind of how it is. But please make sure you know them. So that is all for this slide. I'll wait a second so y'all can finish writing this down. Okay, I'm going to go ahead and clear the screen, so if y'all need to still continue to write, then you can pause the video. Otherwise, I'm going to go ahead and clear the screen now. I don't know how well this video will stream over to y'all through Dorsey, but the link is on the slide that we just left. It's a really cool illustration, I think, because it shows you, the earth cut in half. So you can see the core down towards the middle. You've got the mantle and you've got the crust on top. Now, when I play this, you can see the convection currents that are going on in the mantle. So here you have the magma coming up, and these two plates are going away from one another, so this is a divergent boundary. Now, since this is a divergent boundary, you are going to have the ridges over here. Those are those bumpy things. This is the rift valley, because remember, if you have a rift, you have a separation. And as this magma comes up and cools and hardens, that is going to be that new ocean floor. So this is your divergent boundary, and then the next one it's going to go to is going to show you a convergent, and you can watch as the plate goes down into the magma and is melted. So let me go ahead and play that. So this is divergent, and this is the convergent one. So I want to pause it real quick. This is the subduction zone along here, because that's where it's going underneath. So this area is what would be the ocean trench. And down here, this is where it's going to melt and then eventually come up to form some volcanoes. So again, with that in mind, I know it's probably a little choppy looking, but let's go ahead and watch it. So the plate's going below. There's the divergent again, and it's showing you divergent, and then there's two convergent ones on either side of them because of that convection. And so in just a moment, it will go back. There's lava. There, this is our convergent zone. So let's look right here. Again, because I know you're probably tired of me repeating this, but oh well. You've got the subduction zone here. This is your deep water trench, and here's your volcanoes, because this comes up as it gets melted and comes out as a volcano. Eruption. Okay. Keep going in our notes. So we have done 2 of our convergent boundaries. Now we have one more convergent boundary. Let my screen catch up to us. So here's our last convergent boundary. So now we have continental, continental. So the 2 continental plates coming together. Again, as always, this is convergent. So now you have these 2 plates that are coming together. I don't really know how to draw this one, but you got the 2 plates coming together. And when they do, they're equal density, and so they just kind of crush together. So if you imagine getting your hands and holding them flat and then putting your 2 fingertips together. Well, as you move your hands into one another, your fingers go up to form like a little triangle. That would be the mountain. So the 2 continental plates come together. When they hit, they just go up, and there's your little mountain. So that's the only feature made out of continental convergent boundary. What was I going to say? Oh, you don't have to draw this drawing because that's obviously very ugly. As long as you just have the 2 arrows going together, knowing that they come together and they bend to create mountains, that may be a better drawing. But that's your continental convergent. So go ahead and get that written down. That should only take you a second, so I will wait. If it ever asks you for an example of a continental convergent boundary, any mountain would be an example, because that's what they form, are mountains. Okay, I'm going to go ahead and clear the screen so we can go on to our last boundary. The last boundary, so we did divergent and convergent. The very last one is a transform boundary. A transform boundary is simply when you have the plates that are sliding side by side. So their divergent was dividing, convergent was coming together, transform is just sliding side by side. And what they create, the features that you can write down, are faults and earthquakes. So I'm just going to put EQ, but EQ means earthquakes. So it's 2 plates. You can just put, they grind past one another, slide past one another. If you want to ignore this part, you can. And they create faults and earthquakes. Now, the part that I marked out was saying it doesn't produce or destroy the lithosphere. The lithosphere is just talking about the crust. So in a divergent boundary, you have new parts of the lithosphere, a new crust being created. So that's a production. With your oceanic continental and oceanic convergent boundaries, you had one plate that was going down into the magma and being melted. So that was an example of crust being destroyed. So destruction was occurring there because the crust was literally melting and going away. With your transform boundaries, when they just slide side by side, it may break the crust a little bit, but it's not destroying it. It's just making some little cracks in it. That's all that a fault is. And then you can feel earthquakes along those boundaries, but it does not destroy anything. If you're very stressed out, then this plate boundary yoga is always fun to do, but I'm not going to make y'all do that. Maybe when I get back. But the San Andreas Fault is the most common example of this. So here is your San Andreas Fault line. Okay, the San Andreas Fault line is right here. Notice it does cut through a little bit of Mexico, a little bit of California, because that's where the plate boundary is. All of these little black lines stemming off of that, those are faults. So you have your main transform boundary with little faults that are fracturing off from it. And so that's where you can feel all sorts of earthquakes occur. So hopefully you're about done writing this one. Down here you can see a picture of where this line was here and this is here. So they're not lined up. That's because this one scooted one way while this one scooted the other way. So that's the transform boundary. So I'll clear the slide so we can move on to our lab. Yay! I know y'all are tired of taking notes. I'm tired of recording them. So let's keep going. Oh, a couple more things. Evidence of plate tectonics. You have paleomagnetism. Everybody say paleomagnetism. Paleomagnetism is simply saying it's the magnetization of rock. So remember, our core of the earth has a magnetic force in it. And so that magnetic force can be transferred onto different rocks within the earth. And so we can tell rock that was magnetized by the poles have been moved somewhere else. So that is an example of evidence of plate tectonics. Another evidence of plate tectonics is your earthquakes. So we know that earthquakes occur on plate boundaries or near plate boundaries. So because we keep feeling earthquakes by these boundary lines, we know that the plates are indeed moving because that's what's creating the earthquake. My next slide just has two other things for you to write down that are still evidence of plate tectonics. And then we will actually start the lab. So paleomagnetism is just the rock becoming magnetized. That's really all we're ever going to talk about it. And then the earthquake patterns. You do need to understand that earthquakes occur on or beside plate boundaries. That's definitely an important thing to understand. But that also shows us that the plates are moving. So I will wait for a moment. I always feel weird waiting for y'all to write this down because I have no idea how long it's going to take you to write it. And I don't know if you're all done looking at the screen like, move on, this is boring. But I know there are probably some slow writers out there. Okay, next slide. If you really need to pause it, you can, or just get the notes from somebody when we start the lab. Okay, ocean drilling. So this is another form of evidence. When we drill into the ocean, we can take samples of rock and we can see that there is rock that's only like a week old. So that shows us that there is brand new crust being created, which again is evidence of plate tectonics. So where would this new crust be occurring? This would be occurring in a divergent boundary because as those plates divide away from one another, the magma comes up, cools, and hardens to create that new crust. So if you drilled along the mid-Atlantic Ocean ridge, the further away from the Rift Valley you got, the older the crust would be. The closer you got, the newer it would be, or the younger. And so that's how we can tell that there is indeed some movement occurring there. And then our last form of evidence are hot spots. These are not hot spots like the internet device stuff that y'all use. We're actually going to talk about this when we get later into volcanoes. But they're little areas within plates that create volcanoes and move the volcanoes. So I'll explain that stuff later. For now, just go ahead and write down hot spots. And this only had 6 words to write. So, my gosh, that shouldn't take long. Let's go to our lab. So you're about to do a lab that is involving food. Yay, food. I'm going to pull up the lab sheet real quick and then show you something for the lab. Okay, here's the lab sheet that you and a partner are about to get. You're going to get graham crackers, a piece of foam board, wax paper frosting. You probably won't get a knife. all the knife is used for is to spread the frosting. You can use a graham cracker for that. There will be a cup of water in the back. This cup of water is not your group's, it is the class's cup of water. So there's no need to bring that cup of water with you. At one point in the lab, you're going to have your graham cracker broken. You know how you can break them in half so that they're two long rectangles. So you're going to have your graham cracker broken, and it's going to tell you to go back in the cup of water, and you're going to dip the graham cracker into the cup of water. Now, you only need to dip it about like an inch or so up. And the other thing to know about the cup of water is as you dip the graham cracker into this water, do not hold the graham cracker in the water. If you do that, this graham cracker absorbs the water very quickly. It's going to get soggy and it's going to break off and be really gross. So you literally just dip, out, done. Okay, so like 1 second in the water, if that, and then you are absolutely fine. So just go in and then out, and that's fine. So dip, out, done. Don't be the person who makes the water look gross because you held the graham cracker in there for way too long. So that's what you're going to be doing. Switching over to just a couple pictures to give some clarifying images to the instructions. So you're going to spread out the frosting. So you'll get a spoonful or two of frosting and you'll spread it out. You only need enough frosting so that the two halves of your graham cracker can sit on it. So when I say spread out the frosting, it does not need to cover your whole plate or wax paper, whatever you're using. It just needs to spread out in the area about this large, because this is what you're going to do. You're going to have the graham crackers on, two halves of a graham cracker, so one whole graham cracker on the icing, and then you're going to move them on the icing in different ways according to what the lab tells you. So this is an example of a group who spread out their frosting and it was perfect. This is what you'll end up doing. If the whole graham cracker doesn't fit on the frosting, it's fine, as long as at least half of it does. These are other pictures of what it will kind of look like. So you got the divergent boundary. Now, a lot of people get confused because they see this little bump thing appear, but remember, there's bumpy things in the divergent thing, so you can take a look at that later. So again, you can see they just have graham crackers sitting on frosting and they move them based on that. Now, don't eat your graham crackers and stuff until you are done using them. Once you're done with the lab, I'm absolutely fine if you eat your graham crackers and icing. Just make sure that if you have any allergies, the box is back there, the icing's back there. So if you have a peanut allergy, I don't know if there's peanuts in there. You need to check that. Be responsible for yourself. Don't die. That would be bad. But I'll go ahead and let you end the video while y'all do your lab.